In this video I'm going to discuss about the traveling salesman problem using branch and bound technique. Generally in traveling salesman problem, set of cities and the distance between every pair of cities will be given. The objective is to find the shortest possible tour that visits every city exactly once and returning to the starting point. As we can observe in the given graph, there are three vertices are given. We have to find the shortest path that goes through all the vertices once and returns back to the starting vertex. Here we can assume that the starting vertex as 1 and then traverse through all other vertices that are 2 and 3 and finally return to vertex 1. Let's start solving the problem. So this is the given graph. Totally 3 vertices are given, 1, 2 and 3. The very first step is we have to make the cost matrix M. We have to create the cost matrix. So in the cost matrix we'll be just registering the cost of each and every edges between each and every vertices here. So totally there are 3 vertices, 1, 2, 3. So from one, when there are no edge present, we are supposed to write infinity. So from the vertex 1 to 1 there is no edge present, so we have written infinity here. From the vertex 1 to 2 there is an edge with the cost value 4, so we have written 4 here. And from the vertex 1 to vertex 3 there is an edge present with the cost value 2. Similarly, from the vertex 2 to 1 the edge is present with the cost 3. From 2 to 2 there is no edge present, so I have written as infinity, and from 2 to 3 there is an edge with cost value 4. Similarly, for 3 to 1 it is 1, 3 to 2 it is 8, and for 3 to 3 there is infinity. So when there is no edge present, we are supposed to write infinity. Right, so this is the final cost matrix. After writing the cost matrix, the next step is performing the row reduction as well as the column reduction. The very first step is row reduction, and then only we will be able to perform the column reduction. So first we will do row reduction. So for performing the row reduction, we are supposed to identify the row minimum from the entire row. From each and every row, we are supposed to identify the row minimum. The minimum value from the entire row we are supposed to identify. So this is the matrix. Right. So for performing the row reduction, we are supposed to identify the least value, row minimum from the entire row. When we take the first row, look at the first row, total there are 3 values are there, infinity, 4 and 2. Among these 3 values, the minimum value is 2, so fetch 2 and write here. When you look at the second row, the minimum value among these 3 is 3, and in the third row the minimum value is 1. After identifying the row minimum, we are supposed to subtract the row minimum from the entire row. Right, so first row the row minimum is 2, so subtract all these values with the row minimum value 2. Infinity minus 2, infinity. 4 minus 2, 2. 2 minus 2, 0. In the second row, you just subtract all these values with the value 3. Right, so when you do that, you get 0, infinity and 1. Similarly, for the third row, you get 0, 7 and infinity. Right, row reduction is over. Right, the second step is performing column reduction. Column reduction can be performed only from the row reduced matrix. The row reduced matrix is 0, 2, 0, 0, infinity, 1, 0, 7, infinity. This is the row reduced matrix. So now we are supposed to perform the column reduction. So we need to identify the column minimum from the entire column. When we look at the first column, the column minimum is 0. When we look at the second column, the column minimum is 2. In the third column, the column minimum is 0. Right? After identifying the column minimum, we are supposed to subtract the column minimum from the entire column. After subtracting, this is infinity. There will be infinity, 0, 0. When we look at the second column, the column minimum is 2. So subtract all those values, 3 values from the column 2 with the column minimum 2. So we get 0, infinity, 5. 7 minus 2, it will be 5. So 0 minus all these 3 values will be the same only, 0, 1 and infinity. Right. So after performing the column reduction, we get the reduced matrix. So this is the reduced matrix. So after performing the row reduction and column reduction, the upper bound can be computed. So the total reduction cost is, just sum up all the values we used for performing the row reduction as well as the column reduction. For performing the row reduction, we used 3 values, 2, 3 and 1, and for performing the column reduction, again 3 values we used, that is 0, 2 and 0. These are the values we used for performing the row reduction as well as the column reduction. So total we get 8. So this we call it as the lower bound value. So the lower bound value is 8. It means this is the minimum cost required for any tool for the given problem, right? So the lower bound value is computed. Now the main task here is identifying the optimal path which gives you the minimum cost, right? So here, as I told you before, the starting vertex is going to be 1. If you start from the vertex 1, you have 2 options. Either you need to traverse from 1 to 2, you'll be visiting the node, the vertex 2, or else you'll be visiting the vertex 3. You have only 2 options from the vertex 1, either towards vertex 2 or else towards vertex 3, right? So only 2 options we have from the vertex 1. Either we can move on to the vertex 2 or else we can move on to vertex 3. Only these 2 options we have. So through which vertex if you traverse, we will be able to get the least cost. We need to identify now. So before we choose the vertex here, we need to identify which vertex is going to give you the least cost, least upper bound value we need to identify now. So the very first step is, first we identify the lower bound for the path 1 to 2, and then we identify for 1 to 3 as well. So compare these two, 1 to 2 lower bound as well as 1 to 3 lower bound, whichever gives you the least value, we'll proceed from that, right? So the next step is identifying the cost, the lower bound value for the path from vertex 1 to vertex 2, right? So every time, so before we proceed, we are supposed to perform 3 steps. The very first step is fetch the value of 1, 2 from the original cost matrix. So when you check the original cost matrix here, 1 to 2 cost is what? 4. 1, 2, 3, 1, 2, 3. So from the matrix M, 1 to 2 value is what? 4. Store it here. Second step is set row 1, and because it is from 1 to 2, right? So row 1 and column 2 as infinity. Third step is set matrix 2, 1 as infinity. This is a third step. So first step is where we fetch the value of 1, 2 and stored over here. The second step is set row 1 and column 2 as infinity, right? So from which matrix we are supposed to start? Always we are supposed to start from the reduced matrix, right? Because we are starting from the original matrix, like source vertex actually. So this we have to start from the reduced matrix, that is infinity, 0, 0, 0, infinity, 1, 0, 5, infinity, right? So we are supposed to perform these 3 steps. First step is already over, remaining 2 steps you are supposed to perform. The second step is set row 1 and column 2 as infinity. Yes, row 1 and column 2 we made as infinity. And the third step is set matrix 2, 1 as infinity. So 2, 1 is this position, right? So you make this also as infinity. Rest all will remain same, 0, infinity. Now we start performing the row reduction as well as column reduction, because after performing the row reduction and column reduction only, we will be able to compute the lower bound value, right? So first step is row reduction. From this matrix. So already I explained you how to perform the row reduction. Identify the row minimum from the entire row. When you take the first row, all are infinity, so there is no value, no minimum value here. And when you look at the second row, among these 3, 1 is the minimum value. When we look at the third row, among these 3, 0 is the minimum. The next step is, after identifying the row minimum, we are supposed to subtract the row minimum from the entire row. So first row will remain same as it is. Second row infinity minus 1 infinity, again infinity minus 1 infinity, 1 minus 1 0. So 0 minus 0 0, 0 minus infinity infinity, again 0 minus infinity infinity. Row reduction is over. The next step is performing column reduction. Column reduction can be performed only from the row reduced matrix. So infinity 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 0 0 infinity infinity. Identify the column minimum. It is 0 here, nil, again it is 0, right? So all are 0 and null only, so all will remain same. So column reduction is not required here, as we get only 0 and null, right? So row reduction and column reduction is done. Now it's time to compute the lower bound value for the path 1 to 2. Cost of the node 2 or for the path 1 to 2, right? So write the lower bound value. You all know what the lower bound value is, already we have computed and stored here, that is 8, right? So lower bound value is 8 plus, also we fetched the matrix 1 comma 2 value and written it here, right? So fetch this value, matrix 1 comma 2. So 1 comma 2 in the cost matrix, 1 comma 2 value is 4, so I have written 4 here, plus the reduction cost. The values, what are all the values you used for performing the row reduction as well as the column reduction. So when you check here, 1 0 0 and 0 only we have used, right? So reduction cost is 1 plus 0 plus 0 plus 0. So totally when you sum up all this, we'll be getting the cost 17. The lower bound cost is 17. So for the path 1 to 2, the lower bound cost is 13. Similarly, we are just going to identify the lower bound cost for the path 1 to 3 as well. Path from 1 to 3, right? So again you start from the reduced matrix. Start from this matrix, because from the original source matrix we are starting, right? So take the reduced matrix, infinity 0 0 0 infinity 1 0 5 infinity, right? This is our original matrix. Before that we are supposed to perform 3 steps, right? First step is fetch the value from the cost matrix 1 comma 3. So in the original cost matrix, what is 1 comma 3 value? 1 comma 3 value is 2, right? So write it here, right? And then set row 1 and column 3 as infinity, and the third step is set matrix 3 comma 1 as infinity, right? So we are going to start from this matrix only, right? So first step is over, fetch the value matrix 1 comma 3 value and stored it here, and the second step is set row 1, this is our row 1, and column 3 as infinity, right? So column 3 we made as infinity. Also 3 comma 1 also should be infinity. 3 comma 1 is this position, so you make this also as infinity. Rest all the values will be same, 0 infinity and 5, right? So performed these 2 steps now, and now start performing the row reduction as well as the column reduction, right? So row reduction, take the minimum value from the entire row. When you take the first row, all are infinity, so it is null, and in the second row it is 0, and in the third row it is 5. So the row minimum is taken. Now it's time to subtract the row minimum from the entire row, so there won't be any change in the row 1. Same like in this row 2 also there won't be any change, because the row minimum is 0, and in the third row the row minimum is 5, so subtract all these 3 values with the 5. Infinity minus 5, sorry, infinity minus 5 infinity, 5 minus 5 0, then again infinity minus 5 infinity. This is what we get after performing the row reduction. And the next step is performing column reduction. From the row reduced matrix, infinity, 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 0, infinity, 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 0, infinity. So when you check, you just identify the column minimum. So here it will be 0, again here it will be 0, here it will be null. So it will remain same only because all are 0 and null. Right? So after performing row reduction and column reduction, it's time to calculate the lower bound value. Cost of the path 1, 2, 3 is, the formula is lower bound plus matrix 1, 3, the cost 1, 3 cost plus total reduction cost. So under path 1, 2, 3, what are the values we used for performing the reduction? We need to write here. So 0 plus 5 plus 0 plus 0. This is our total reduction cost. We all know the lower bound value is 8 and 1, 3 cost is 2, right? So 2. So total we get 50, right? So for the path 1, 3, we get the cost 50, right? So from the vertex 1, we had two options. Either we can move to the vertex 2 or else we can move to the vertex 3. So now we need to choose one optimal path, like one optimal vertex. From which vertex if you start, if you continue, we'll be able to complete the tour with the minimum cost we need to identify. For that, we just performed some steps for calculating the lower bound for the path 1 to 2 as well as for 1 to 3. So for path 1 to 2, we got the lower bound value as 13, and for the path 1 to 3, we got the lower bound value as 15, right? So when you compare these two, the vertex 2 has the least lower bound value. So we are supposed to proceed from the vertex 2 only. So look at the original graph. From the vertex 2, what all the possibilities are there? So from the vertex 2, either we can move to vertex 1 or else we can move to vertex 3. Only two options are there, right? So without visiting all other vertices exactly once, we can't go back to the source vertex. So with one it is not possible. So the only option is moving to the vertex 3, right? So there were two options, either to vertex 3 or else to vertex 1. So since we haven't visited all other vertices, we can't go back to the source vertex. So moving towards the vertex 1 is not possible. So the only possible option is moving to the vertex 3. So now for path 1 to 2, we already computed the lower bound value, that is 13. We already computed the cost. But for the path 1 to 2 to 3, we haven't computed the cost yet, right? So now it's time to compute the lower bound value for the path 1 to 2 to 3, right? So again, as usual, 3 steps everywhere we are supposed to perform. The very first step is, it means what? 2 to 3 we are supposed to identify. So already 1 to 2 already we have computed, right? So from 1 to 2 already we have computed. From here we are just going to move to the vertex 3, right? So the very first step is, from the original cost matrix, fetch the value of 2, 3. So check the original cost matrix. This is our original cost matrix. So yeah, so from 2 to 3, what is the original cost matrix? It is 4. For 2 to 3, the original cost matrix is 4. So write 4 here, right? And then set row 2 and column 3 as infinity, and also set in the matrix 3, 2 as infinity, right? Okay, from which matrix we are supposed to start from. So we are just going to start from 2 here. Already from 1 to 2 already we have computed. From here we are just going to traverse, right? So take the reduced matrix of 1 to 2. Go to the path, go to the step path 1 to 2. So where is the reduced matrix? After performing the row reduction as well as column reduction, this is the reduced matrix we got, right, under path 1 to 2. We are supposed to use this reduced matrix only here, right? So infinity, take this reduced matrix, infinity, 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 and the second row is infinity, infinity, 0, and the third row is 0, infinity, 0. Right? Now, what are we supposed to do? We are supposed to perform set row 2 as well as column 3 as infinity, right? So second step is set row 2 and column 3. So row 2 is this and column 3 is this, right? We made all this as infinity. Rest all will remain same, infinity, 0, infinity, right? And also 3 comma 2 also should be infinity. So 3 comma 2 is this part. So already it is an infinity. So we just applied both of these steps. So after applying these two, we are just getting this as the final matrix. Now you start performing the row reduction as usual as well as the column reduction, so that we'll be able to compute the lower bound value. So this is the matrix, original matrix. Now identify the row minimum. There is no row minimum value. Here also it is null, here it is 0. Since all are null and 0, it will remain same only. Next, column reduction. Right? So again, when you try to perform column reduction, we keep getting 0 and null only again. So column reduction also can't be performed because already it is column reduced. 0, null, null, right? So again it will remain same only. Right? Now it's time to compute the upper bound value for the cost 1 to 2 to 3. So the formula is lower bound plus matrix 2 to 3, right? So from the original cost matrix, the 2 to 3 cost is 4, and the total reduction. So we haven't used any value to perform the row reduction as well as the column reduction, so it will be 0. And the lower bound value, lower bound value of what? From this 1 to 2, right? So for 1 to 2, what is the lower bound value we got? So go to path 1 to 2. So what we got? The lower bound value, it is 13, right? So write 13 here. So after adding all these values, we get the final cost as 70, right? So for 2 to 3, we get the minimum cost as 70, right? Then again from 3, so we have visited all the vertices, vertex 1, 2 and 3. After 3, there is no more new vertex to visit actually. So after visiting all the vertex 3, it is supposed to move back to the source vertex only. So we have visited all the vertices exactly once with the minimum cost of 70. So the optimal path is 1 to 2 to 3 to 1. This is the optimal path with the minimum cost of 70. Because when we look at the tree, this is the final tree. So the path is 1 to 2 to 3, and then you can go back to the source vertex. So the path is 1 to 2 to 3 to 1, and the final cost is 70. The minimum cost is 70. Thank you.